Alright, welcome everyone to this video. So, this video I'm going to be talking about Simulink and what it's useful for, the elements of it. If you are a Chicago College student taking Engineering 25, I would highly recommend watching this video. I'm going to go over basics of Simulink, so hopefully this video will help. So the first thing I want to start off with is outlining basic elements of really what I believe is what Simulink is generally. So the first element of Simulink is that it's a software tool which simulates outputs. Now, when we think about an output, right, we think about how, you probably already know this from basic algebra, that usually when we see, when we want to understand what an output is, humans could look at an equation and they can understand that an output is something from which an input is going to be, is some kind of number, maybe some kind of logical category. So, meaning an output can be y equals, say, x plus 2, right? So this is very basic. Y is the output, x is the input. The result is adding whatever x is to 2, as long as it's a numeric. So this is very basic. And also, some other outputs can also be more complicated. Like, for example, say you want to get y such that y is equal to the double derivative of, say, y prime x plus x squared, and then dx, right? Or sorry, dx, right? So when you look at such an equation, let me bring this over a little bit. When you look at such an equation, you might be able to solve it with some differential equation techniques, but it's very odd looking for somebody who is even a differential equation expert. But what we can do is we can do something so that we can numerically attain this, such that if we know what x is, if we know what y prime is, so the numbers relate to y prime, x, then we can integrate those values and with maybe some numerical analysis, such as using Laplace transformations. And you'll see that that's the reason why the icon for integration in Simulink is, in fact, supposed to be a quote-unquote Laplace transformation. So these are some other outputs. You can have so many different ways that humans can understand what an output is, but and it's most simply it's most simply given by some kind of equation. So that's the reason why the first element of the Simulink is that it's a software tool which simulates outputs. But it's you can understand the output first without a map, or I guess you can think of it like a map by an equation. So before you start to use Simulink. So the second element is that it's a numeric logic system. So the first kind of example I meant when I say a numeric logic system is that it can be used to make control systems. So a control system is basically something that will help you organize information based on behavior of the system. So, for example, we might have that T temperature is going to be maybe this weird. You might have an equation that might be dt, d temperature dt, maybe plus t times t equals f of t. And basically this is just some random number in this case. And then here, what if we gave the condition such that t has to be greater than 90? For t greater than 90, we say that t t is equal to 0 or something like that, and if t is less than or equal to 90, we say that t is equal to t. So it's just whatever it is at that time, right? So here what I've done is I've given a condition, and so to outline this, where we know that there's a certain behavior for the temperature at some certain time, and namely 0, and then t equals t at some other time. So this would be considered, you would, in order to simulate this, you would use a control system. And so you could basically model the control system using Simulink. And you'll see a problem like that for the Chabot College students. You'll see a problem like that in your homework. So just keep that in mind, that Simulink is not just about necessarily simply about outputs, because you can still use it for things like this, where it's kind of models behavior of a system. So now the third thing I wanted to go over is it's similar to digital logic circuits, if you know anything about that. So an example of a digital logic circuit would be something like, let's think, a JK flip-flop. And now, let me think about that. So you might have something like this. Now I know this is not going to make much sense to students here, but that's just try your best to understand where I'm coming from. So you have something like actually this is an OR, I think. So JK flip flop, you might have something like that, and then here we have an input going that way, or two inputs, another input here. And so let's say here we're stealing the input here, and then we're stealing another input here. And so this would basically be this is called JK flip flop. What it does is that for a JK flip flop, if you draw a truth table, basically you'll notice that this thing, with the output of it, is going to basically toggle. So I guess I'll send a link to a video of this guy named Jack Buffington from robotreview.com. You'll probably understand it better. He can probably explain it better than I can. It's difficult to understand. Even Bruce Mayer claims that it's very tricky. He says that each time he looks at it, he just can't really fathom it. So it's similar to this, because what happens is if you so-called quote-unquote feed a number or some input, then you can actually steal, then it can be like quote-unquote stolen and or fed through another part of the circuit. In other words, you can have the input go through here and another part so that you have an output that's going to differ if you didn't do that. Or that might work for something some kind of control system you're just trying to model. So that would be the basics of Simulink. Hopefully that helped. In the next video, I will show you examples of how to do these, of what you can get. And so this would be helpful. So there are different problems you'll probably see. By request, I'll actually do a problem if you want me to for the Chabot College students. So thanks for watching the video. Hope you understand Simulink from a more general perspective. And that will probably help you to kind of fathom the different information that you have to work with for the use of Simulink. Thanks for watching.